Electric flux. The concept of flux describes how much of something goes through a given area. You may conceptualize the flux of an electric field as measure of the numbers of electric field lines passing through an area. For discussing the flux of a vector field, it is helpful to introduce an area vector. The area vector of a flat surface has magnitude equal to area and its direction is along the normal to the surface as shown in figure. The electric flux is denoted by phi E for uniform field E and area A. Electric flux is defined as the measure of number of lines of force that pass through the area placed in the electric field. Flux is the scalar product of electric field and plane surface area. Flux is equal to E dot A and E dot A is equal to the E A cos theta. The electric flux depends upon surface area, electric field intensity, the orientation of surface area with respect to the field. Flux at any angle. If the area is titled such that it is making an angle with the electric field line as shown in figure. In this case, the electric flux is the number of lines passing through the area will be Ea cos theta depending upon the angle. If the surface is placed perpendicular to the electric field such that surface area is parallel to the electric field, then maximum electric field of force will pass through the surface as shown in figure. Consequently, maximum electric field lines will pass through the surface. The electric flux is Ea cos theta. Therefore, large number of lines pass through the surface to the area. Zero flux. If the surface is placed parallel to the electric field such that surface area is normal to the electric field, then no electric field line of force will pass through the surface as shown in figure. Consequently, no electric flux will pass through the surface. Electric flux through closed surface. If the case is such that either field is not uniform or the surface is curved, we divide the surface into very small patches of area called differential area and assume that these are approximately flat and they are so small that electric field is almost uniform over it. For one of these small patches of areas as shown figure, the electric flux is defined by the relation. To calculate total flux through the whole surface, we add the flux from each patch such that flux is equal to summation of E dot total area. Do you know? In case of closed surface, the flux, electric flux may be positive, negative or zero depending upon the number of lines entering or leaving the surface. Positive, negative and zero flux through a closed surface. First, electric flux is zero if number of field lines entering are equal to the field line leaving the surface or no field line intercepting the surface and shown figure. The electric flux is negative if net numbers of electric field lines are entering the closed surface or more field lines are entering than leaving the surface as shown figure. The electric flux is positive if net number of electric field lines are leaving the surface as shown in figure. Now the Gauss's law. The electric field is of a given charge distribution can be calculated using Coulomb's law, but sometimes the actual calculation can become quite complicated. An alternative method to calculate the electric field of a given charge distribution relies on a theorem called Gauss's law. Gauss's law provides a relation between the net electric flux through a closed surface and the net charge enclosed by that surface. Cauchy's law states that the net electric flux through a closed surface is equal to the total charge enclosed by the surface divided by the permittivity of free surface.